Hi everyone, welcome to another tutorial. In this tutorial you will learn how to use the Geopandas Python library in order to plot geographical data. Now before you get started, let's open a new Python script. For that you can go to your file explorer over here. Let's right click and go to a new module, and I will name this as plotting geographical data .py because it's a Python file. Alright, so let's go ahead and first import the Geopandas library. We import the library by typing import as gpd, and now what I'm going to do is I'm going to read in one shapefile. Now you can see over here I have one shapefile by the name of world. So this is basically a shapefile of the world. So I'm just going to read this file in using the Geopandas library. So for that I can first create one variable to which I will actually load this shapefile. I'm going to call it as world data. Let me put a comment over here and describe what I'm actually going to be doing. Alright, so world data is actually going to be equal to gpd because I'm calling the Geopandas library read file, and what you have to do is just provide the path to the corresponding shapefile. So I can just go ahead and copy this and paste it over here, followed by world.shp because .shp file is the shapefile that we are going to read in. Now to run, you can just either press here or you can just simply hit F5, and now you can see that we did not get any error or anything like that. Now you can actually have a quick look at this world data variable. But if I make a slight adjustment over here, you can see that we've got a couple of columns and then we have some information. Now let's use the variables explorer, which provides us a bit more clearer picture of the details embedded in this variable. Now you can see that we actually have some information over here. We have the name, and we also have a column for area, some other information like the region, sub-region, longitude, latitude. Just something to keep in mind is that this geometry column is actually not originally included in the shapefile, but when you read in data using Geopandas library, the way the program identifies the geographical locations of each element, in this case these are actually polygons, so the way it identifies the location of each polygon is actually using this geometry column. So this is basically a special column which gets created when you read in geographical data. Now if I check the type of world data, it'll tell you that it's not actually a pandas data frame, but it's a Geopandas geodata frame. So the way how this geodata frame actually differs from a regular pandas data frame is through the availability of this special geometry column, which actually gives corresponding geometrical properties. Now you can do a quick visualization. What you can do is you can just say world data.plot, and that'll give you a quick plot of the data that you saved into this world data variable. So this is how the map looks. Now I'm just going to make a few changes. Let's say that when we go to the variables explorer, right now you see that there are actually multiple columns over here which I might not really require. So instead of getting rid of all the columns that I do not need, what I'm going to do is instead I'm going to select only the columns that I need. So for example, in this case I'm just going to select this column, which is by the name, which actually gives the name of the country, as well as this important geometry column. We cannot miss this because if you don't read this one in, it'll lose its geometrical properties. Basically it'll get converted into a pandas data frame instead of it being a Geopandas geodata frame. So I'm going to read in these two columns. You can say world data equals world data Now, if you want to just select only one column, you can just have a single pair of square brackets. But if you're going to select more than one column, it could be 2 columns, 3 columns, or any number of columns which is more than one, you actually have to have 2 pairs of square brackets, and inside those you specify the names of the columns. So as you can remember, the name of the column which contains the names of the countries was actually in name, and the other column which had the geometrical properties was named as geometry. Alright, so what we do over here is we pick those 2 columns and then we save that information into the same variable name. So basically whatever the data that we had before under world data will get sort of replaced by this new pair of columns. Alright, now we can run this, and now if I say that world data, you see that we just have 2 columns. Now you can just make sure that it's just 2 columns by saying world data dot columns, and that will give you whatever the columns that we have inside here. Since we retain this geometry column, even if you say now world data dot plot, it will plot the figure for you without any issue. And even if I go back to the variables explorer and if I open this over here, you can see that we just have 2 columns now, but under the same world data variable name. So that's how you do that. Now let's say you want to calculate the areas. Let's say we need to calculate the areas of each country. You don't have to do much. You can create one column over here called areas, and you can basically use Geopandas to directly calculate the areas as well. Now let's say that calculating the area of each country. Alright, what you can do is, in order to add a new column, you can just specify the name of the variable that you have, and over here just inside the single square brackets, just include the name of the column, the heading of the column which you would like to include. In this case I would like to have the name as area because it's quite straightforward. And then what you can do is you can just specify the geodata frame's name again and just say area. Alright, now you can run this, and now if I say world data dot columns, you will see that we have a new column called area. And if you would like to display the data, you can just say world data dot, if you would like to just display the first 15 entries, you can say world data dot head 15. Now this dot head is actually coming from pandas. Now even though this is Geopandas, you can actually still use the functionalities of a majority of the functionalities of pandas as well. So that's why you can use this without any issue, and it will give you the first 15 entries. And you can see that over here we have another column called area. Now you can even visualize this using the variables explorer. If you double click over here, you can see that we have an area column. But now you might just wonder why the areas are a little bit low. Now one thing to keep in mind is that originally this shapefile is in WGS84 geographic coordinate system, and the unit is actually in decimal degrees. So the area that you see over here is not in square kilometers or in square meters, because it calculated the area using its original base unit, which was in decimal degrees. So later on I will show you how to convert this into a different coordinate system. But for the time being, I just wanted to show you that we can do this kind of an operation just to calculate the area in a very straightforward manner. But calculating the area maybe in square kilometers or square meters, we'll do it in one of the upcoming steps. Alright, now if I again just quickly do a plot, world data dot plot, you can see that it's basically covering the entire globe. But let's say if you want to get rid of one of the countries, let's say in this case I want to get rid of this whole Antarctica continent, because it's not really relevant for any of the operations that I'm going to do. So let's say I want to get rid of Antarctica. So let's see how we can do that. So again, I'm going to use the same variable name as world data, and only this time I'm going to specify world data. Now all the names of the countries, and in this case even the name of the continent Antarctica, is under this column name. So I would like to say that over here, name not equals to Antarctica. Now the exclamation mark followed by the equal sign is basically the notation in Python for specifying not equals. So that's why we say that. Now let's run this one and see. Well, we can just say world data dot plot as well. And let me just get rid of this one so it won't confuse us with two equal plots. Or maybe let me retain that so that we can see how the second plot actually differs from the first one. So now when I run this, alright, now you can see that this one, basically before we did anything to Antarctica, that plot refers to this one, and the second plot, which refers to this figure, you can see that the Antarctica is basically gone. Alright, now let's talk a bit about projections. Now first I would like to know what sort of a projection is assigned to my current shapefile. So let me put a title saying that changing the projections. Alright, so let's say I would like to know what my current coordinate system is. I will create a variable called current CRS, and the way to check the coordinate system of a shapefile using Geopandas is basically by saying world data, that's your Geopandas geodata frame. You just say CRS, which stands for coordinate reference system. Now if I run this, and now if I say what is my current CRS, we'll see you will basically get the EPSG code. Now if you would really want to know what this EPSG code refers to, what you can do is you can just Google and see. Let me open my web browser. Now I just googled EPSG 4326 and let me go to the first link, and it'll actually provide you with all the information that you need to know about the EPSG 4326. So this is basically the World Geodetic System 1984, WGS 1984 coordinate system, which is a geographic coordinate system, and the units are in degrees, in decimal degrees. Even if you go to this variable explorer and if you open the geometry column, if you actually have a look at this geometry column a bit carefully, you can see that these numbers are actually also formed using the decimal degree values. For example, over here you can see that all of these values are actually in decimal degrees. Now just keep that in mind for a second. Now let's go ahead and convert the current projection of my shapefile into a projected coordinate system. Because if you're calculating areas, it's better to have a projected coordinate system of which where the units are basically meters, so that we can get a much more familiar representation of the area where lives. So let's see how we can do that, how we can change the projection. Now one way of changing the projection is by saying world data to CRS. Now you can see that it also shows us which arguments are necessary. Now if we know the corresponding EPSG code of a project system, of a projected coordinate system to which you would like to project your data into, you can just provide the argument saying that EPSG equals a certain coordinate system. Now let me search for the EPSG code 3857. Now this EPSG 3857 basically refers to this WGS84 pseudo-Mercator projection, which is basically used by many of the famous maps such as the Google Maps, the OpenStreetMaps, the Bing Maps, and over here you can see that the unit is in meters. So what I'm going to do is I'm going to specify this EPSG code. I have to provide one more argument called inPlace. Now the meaning of this inPlace argument is that inPlace equals true. That means you're actually changing on the spot the original properties of this world data geodata frame from being a geographic coordinate system into a projected coordinate system corresponding to this EPSG code. So that's basically the importance of this inPlace equals true argument. And now let me go ahead and say world data.plot. Alright, now let me go ahead and get rid of this because we actually don't need too many plots, just to avoid us from getting confused. Right, now let's go ahead and run this. Right, now you can see actually the differences between even how the projection itself looks whenever the data is in geographic coordinate system and when we transfer it into this corresponding projected coordinate system. You can see that the map has been stretched a little bit, and if you've been working with Google Maps or S3 maps, I think this map format looks a bit more familiar to you guys, isn't it? Because they also use the same projected coordinate system to represent their maps. So even if you now go back to the variables explorer and go to this geometry data, you can now recall that previously all these values were in decimal degrees. Now you can see that the values has been changed from decimal degrees into meters. So that happens when you do the conversion of the coordinate system. Now let's say that you want to color this map, let's say based on each country. Now you can do that simply by passing an argument over here called column. Color it by say we'll see the first 5. Let's say we need to color it by the name of the country. So what you need to do is you have to pass the heading of the column name by which you need to get the map colored, and you can also specify a color map by passing the argument called CMap. And there are different color maps such as jet, rainbow. If you have a quick look at the Matplotlib documentation, you will actually be able to see the full list of different color maps as well. Alright, now let's go ahead and run this command. Now you can see that it more or less got colored based on different countries, as you can see over here. In case if you're interested in knowing more about these different color maps, you can see that all of these are different color type. All of these are different color maps that you can actually use. Now you can see that we have the name over here as, let me try this HSV. Now if I say HSV instead, it should look quite similar to jet, but let's see. Yeah, you can see that it's a different color scheme. So just like that, you can actually have quite a wide array of different color maps to actually choose from. So I'll put the link of this in the description as well. If you guys would like to just play around and see different color schemes, you can do that. Alright, so that's how you change the colors of the plot based on the column, based on a specific column. So if I go back to the variables explorer, now you can see that previously we calculated the area when the coordinate system of the geodata frame was in WGS geographic coordinate system. Now since we have already done conversion from geographic coordinate system into a projected coordinate system, now let's go ahead and change this one and recalculate this area so that the areas will be represented in square meters or either in square kilometers. Let's try to put it in square kilometers because that figure will be a bit more familiar to us. Or I would say recalculate the areas in square kilometers. Alright, similar to what you did over here, you can basically do the same thing, but only this time I will divide the whole thing by 10 to the power 1, 2, 3, 4, 5, 6, 10 to the power 6, because if I don't do that, the areas will be in square meters, which are basically going to be huge numbers. So when I divide it by 10 to the power 6, it'll get converted into square kilometers. And now if I go back to the variables explorer, you can see now the areas are calculated in basically square kilometers, which are quite easily readable. Alright, so that's how you do that. Now let's see how we can add a legend into this. Adding a legend, what you basically have to do is just pass a couple of more arguments to what you did over here. So I can still say world data.plot, and this time I'm going to specify the column, and we can also specify the CMap. And apart from that, we can also specify the legend to be equal to true. Now this is a boolean, so we specify that to be equal to true. Now here you remember that for this plot, actually I assign the colors based on the name of the country. So similarly, we can also assign the colors maybe based on a different parameter. Now we do not have any other realistic parameter other than this area. Now it would have been good if we had another column, like maybe either the population or the GDP or something like that. Just for the sake of teaching you how to do this, let's actually go ahead with the area column. So what I can do is I can specify the name of the column over here, which is area, and the color map I'll still use the same HSV, and now I can just go ahead and run. Yeah, now you can see that we also managed to get a legend over here, and accordingly you see that the colors in the plot also got changed. That's because now each and every color that you see over here basically refers to a value, which is the area in square kilometers. But if someone were to look at this map for the first time, they wouldn't have a clue what these numbers are, isn't it? So it would be actually good to have some sort of an indication for the legend as well. So you can do that simply by passing another argument called keywords. And over here you can specify a label for the legend. So let's say my label over here is going to be area of the country in square kilometers. Alright, now you can just run this one and see how it looks. Alright, now you can see that we managed to sort of get an indication of what this legend basically refers to, area of the country in square kilometers. You can even change the size of the plot by passing another argument called fig size over here. Let's say if you want to sort of increase the size of this figure, you can simply do that by passing another argument called fig size. Let's say 7 by 7. And now if you run this, you see that we actually got the previous figure sort of stretched out a little bit. But as you can see over here, the legend is actually not sort of fitting very well when compared with the map itself. So I would like to see how I can resize this legend. So you can actually do that quite easily using the MPL toolkits of Matplotlib library. So what I'm going to do is I'm just going to first import as PLT from MPL toolkits access grid 1. I'm going to import make access locatable. So let me go ahead and say that what we are going to do over here is resizing the legend. You see that we imported the pyplot object of Matplotlib library as PLT. So what I'm going to do is actually I'm going to use the method called subplots of pyplot object in order to make this plot. So the conventional way of doing it is actually by specifying the figure and also the axis, and now we call the PLT subplots method. Now by default the subplots method actually creates a figure and creates a number of rows and columns. Now by default, if you don't say anything, it'll look something like this, which basically refers to the n number of rows, and the columns is actually one by one. So I'm not going to pass any arguments over here. Instead I'm just going to pass one argument called fig size, and I'm going to return the fig size to be the same, which is 7 by 7. And then I'm going to specify another variable called divider, and this divider is now going to be equal to make access locatable, what you imported over here. Alright, now I'm going to specify another variable called cax append access. Now you can specify the position over here. Either you can put maybe left or right or bottom. Maybe we'll put it in the left side. And you can also specify the size, let's say 7%. Alright, so finally we are going to plot this world data dot plot. Now instead of typing everything again, I'm just going to go ahead and import these arguments like this and specify that the axis is equal to ax, and specify the cax, which is basically the axis into which the color bar will be drawn, and that one I'm going to specify as cax over here. And now let's go ahead and run this command. Alright, now you can see that the legend actually got resized, but it seems like putting the legend on the left side is not a good idea, isn't it? So let me just go ahead and change this to be on the right side, and let me increase the figure size to maybe 10 by 10. Alright, so before I wrap up the tutorial, I would also like to pass another argument over here, which is called pad, which basically refers to the fraction of the original axis between the color bar and the image axis. So I'm just going to pass a value of maybe about 0.1. So what it's going to do is it's actually going to create a small gap between this map and your color bar. So it won't look as if this color bar has been attached to the map. Just it creates a small gap. That's it. So we'll run this one and see how it looks. Alright, now actually the map looks quite alright. So I guess that concludes this tutorial. Of course, there are so many other things that you can actually discover by yourself, especially by reading through the Matplotlib library, how you can incorporate those functionalities into making your map more meaningful and also more presentable. But the main intention of this tutorial was just to provide you sort of an outline so that you can see what sort of things we can do using this Geopandas library and the plotting capabilities of the Matplotlib library. So thanks a lot for watching, guys. I'll see you in the next one.